Hi guys, this is Kamal. Today in this video we are going to learn about a survey on attacks and their countermeasures in deep learning, like applications in deep neural networks, federated transfer and deep reinforcement learning. A survey on attacks and their countermeasures in deep learning. Deep learning is reevaluating various domains, but its security vulnerabilities are growing in a corner. This presentation explores the landscape of attacks targeting deep learning models and investigate effects countermeasurements to the robustness. Applications of deep learning. Image recognition. Deep learning excels at image recognition tasks, powering applications like facial recognition and medical diagnosis. Natural language processing. Deep learning models are transforming language related tasks, including machine transformation and sentimental analysis. Autonomous systems. Deep learning plays a crucial role in enabling autonomous vehicles and other robotic systems. Attacks on deep neural networks. First one, adversarial attacks. Second one, data poisoning attacks. Third one, model extraction attacks. In briefly, we can go into the deep of adversarial attacks. These attacks involve introduction subtle changes into input data that cause missatisfactions, which leads to loss of data. Next, we can go through poisoning attacks. These attacks target the training data, corrupting the model by introducing malicious examples. Moreover, we can go for the model extraction attacks. These attacks aim to steal a copy of the trained model by query it with specific inputs and analyze its responses. Adversarial attacks. Fast generating signs method. A common adversarial attack method that adds a small calculated perturbation in the input data. Projected grand description. A more sophisticated adversarial attacks that uses iterative optional to find more effective. A powerful adversarial attack method that aims to find the smallest possible to cause missatisfactions. Data poisoning attacks, backdoor injection, label flipping, data augmentation. These three are the main data poisoning attacks. Backdoor injection, which is in the way of inserting malicious pattern into the training data that trigger specific behaviors in the model. Label flipping. Label flipping means changing the labels of the training data points to the mislead of the model during training, which will cause several attacks on the humans. Data augmentation. Adding corrupted data points to the training set of degraded the model's accuracy. Model extraction attacks. Query model, analyze response, reconstruction model. Initially, we can go for query model. An attacker queries the target model with various inputs to gather information about its internal workings. He can input some different types of queries. If they work, he will get all the data. If he won't get, then he will do some changes in the queries. Then next tries, he may get the data which will last for the model owners. Analyze responses. The attacker analyzes the response of the target model to identify pattern and extract its parameters. Moreover, reconstruction model. The attacker uses the gathered information to reconstruct a copy of the target model so that without knowing to the owner. The attacker is able to build a similar kind of model, and he can able to sell for almost similar price to the main model, and he can earn lots of money. Countermeasures for deep neural network attacks. Adversarial training the model on adversarial examples to improve its robustness against these attacks. Defensive distillation, a technique that uses knowledge distillation to make the models susceptible to advertise examples. Input pre-processing, applying filtering and normalization technique to the input data to remove potential advertisal permutations. Attacks and defense in federated learning. Data poisoning. Malicious client can corrupt the global model by sending poisonous data updates. Model poisoning. Clients can send a poisonous model update to influence the global model behavior. Backdoor attacks. Injecting backdoors into the global model by sending specific poison updates. Defense strategies. Techniques such as secure aggregation and differential privacy can mitigate these attacks. Attacks and defense in transfer learning. Source model poisoning. Attacks on the source model can impact the performance of the transfer model. Adversarial transfer attacks. Advertiser example generated for source model can be transferred into the target model. Defense strategies. Robust transfer learning techniques and adversarial training can help address these vulnerabilities. Attacks and defense in deep learning reinforcement learning. Policy poisoning. Manipulating the reward function to induce the agent to learn adversarial environments. Modifying the environment to mislead the target and cause the it make to incorrect decisions. Defense strategies. Techniques like robust reinforcement learning algorithm and adversarial training can enhance security. Thank you for your valuable time.